Good morning and good evening, and welcome to our webinar, Demystifying Artificial Intelligence, a conversation with AI insiders and social changemakers, hosted by PKF O'Connor Davies. All attendees are in listen mode only. Before we get started, I'd like to go over a few housekeeping items so you know how to participate in today's call. We've taken a screenshot of the attendee interface, and you should see something that looks like this on your computer desktop in the upper right corner. You will have the opportunity to submit text questions to today's presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the webcast. We have a lot of material to cover, and if time permits, we will make an effort to respond. If we cannot get to your questions, a response will be sent post-event. A recording of today's webinar will be made available to you via email a few hours after the event. At the end of the webinar, we do have a very short survey, which will be prompted, and your response is greatly appreciated. At this time, I would like to introduce Rachel DiDio, partner with PKF O'Connor Davies. Rachel?
Thank you, and hello, everybody, and thank you so much for joining us today. I'm Rachel DiDio, an audit partner here at PKF O'Connor Davies, which is one of the nation's largest public accounting and advisory firms. We provide audit, tax, valuation, and other consulting services to clients in a variety of industries. We also provide services on a worldwide scale, thanks to our leadership role in the PKF International Network of Accountants and Business Advisors, ensuring our clients access to expertise and serving as liaison to more than 400 member firms located in 150 countries. Earlier this year, my fellow partner, Suma Chander, who will introduce herself shortly, was named to the W20 Summit Digital Transformation Task Force. The W20 is the official engagement group focused on gender equity. The group's role is to provide policy recommendations on how to bridge the digital gender divide and submit them to the G20 leadership. As part of PKF O'Connor Davies' partnership with the W20 Task Force, we'll be hosting a series of webinars, the first of which you're attending today on Demystifying Artificial Intelligence, a conversation with AI insiders and social change makers. Today, we will have two wonderful speakers who are specialists in their areas of expertise. We will discuss important topics such as artificial intelligence and how social policymakers are adapting to AI and the integration of AI into various industries in the public and private sectors and how to leverage its potential. Throughout the webinar, there'll be an opportunity to ask questions. We'll also send a follow-up email after the webinar with our contact details to keep the conversation going. With that, I'll turn it over to Suma.
Good morning, everyone. Thank you so much, Rachel. It's such a pleasure and privilege for me and my partners, Rachel and Kelly, to be hosting this webinar today, which is one of the first of the series of events. I'm the practice leader of technology advisory at PKF O'Connor Davies. PKF O'Connor Davies is a knowledge partner of W20, and we have been on the Digital Transformation Task Force that has been working on policy recommendations of the G20 leadership and on how the latest innovations in technology, including artificial intelligence, can be regulated so that the society is adopting to the changes ethically, equitably, and efficiently. We have two wonderful experts today with us, Dr. Ramakrishnan, who's a professor of artificial intelligence, who will talk to us about demystifying artificial intelligence, and Ms. Nishtha Satyam, who's the head of United Nations Women, Timor-Leste, on how social change is adopting to technology innovation and the increasing challenges in the gender digital divide. I will then be moderating a few questions to both our speakers, and we will then be opening the questions to the audience. I will now turn it over to Kelly, who will introduce our speakers. Kelly?
Thank you, Suma. Good morning, everyone. It is a great honor to co-host this webinar today with my partners, Rachel DiDio, Suma Chander, and the two amazing experts. I'm Kelly Lin, a tax partner from PKF O'Connor Davies. I'm also a co-leader of our firm's China desk and work closely with our member firms from the Asia Pacific. 20 years ago, when I started my career at one of the largest accounting firms, as a tax accountant, we reviewed and managed the data manually. Fast forward today, Innovation and the frontier technologies like AI, artificial intelligence, are making things efficient and easy, but also introducing other challenges. Using AI and other technologies has changed our life and will continue to change. Due to the utilization of technologies, roles and responsibilities are shifting. Given the importance of this and the pace of technology innovation, it is critical for us to understand what AI is and how can we adopt AI efficiently and ethically. With that, I would pass on to our first speaker, Dr. Ramakrishnan, Professor of the Practice in Artificial Intelligence and Machine Learning at MIT Sloan School of Management. So prior to MIT Sloan, he founded or was a senior executive in several analytics software companies with a successful exit to technology titans Oracle and Salesforce. His most recent startup, Sequotion, now called Salesforce Einstein for Commerce, is one of the top B2C recommendation engines in the world and influences the shopping behavior of the billions of consumers annually. Post-acquisition, he has served as a Chief Analytics Officer for Oracle's retail business and as a Senior Vice President for Data Science at Salesforce. Earlier in his career, he was a consultant at McKinsey. Dr. Ramakrishnan advises large companies on the pragmatic use of AI to achieve enduring business results and helps startups build and achieve product market fit with AI-powered products. He's also an active angel investor. Dr. Ramakrishnan has an undergraduate engineering degree from the Indian Institute of Technology and MS and PhD from MIT. Dr. Ramakrishnan, thank you for joining us here today. We appreciate your time and insight. The floor is yours now.
Great. Kelly, thank you so much for the warm introduction. I really appreciate it. Hello, everyone. It's great to be here. Over the next 30 minutes or so, I want to share my understanding of what AI is, what it's not, how it actually works under the hood, and then share some perspectives on how to think about its considerable benefits and also considerable risks. So let's dive in. We have a lot of ground to cover. So the field of AI actually originated in 1956 at Dartmouth, and some of the people you see on the slide here, they were the ones who actually came up with the term, and then they actually sort of conceptualized this field as sort of a discrete entity on its own. And some of them went on to become legends in various areas of computer science and information theory, such as Claude Shannon, John McCarthy, Maureen Minsky, and so on and so forth. So it had a very auspicious beginning. Now, in the 67 years since this happened, it has gone through a number of different breakthroughs. And what I'm going to do over the next 35 minutes or so is I'm going to actually cover every one of these breakthroughs so that by the time we are done, you would have had sort of a very fast 7-decade catch-up all done very quickly. Okay, so we will start with an informal definition of what artificial intelligence is. And as you might suspect, it's basically the quest to give computers the ability to do things that traditionally only humans have been able to do. Excuse me. These are typically cognitive tasks, thinking tasks, things that we think that humans are sort of uniquely able to do. So that is really the quest from the very beginning. And the traditional approach to doing so was actually very commonsensical. It basically says, look, if you want a computer to do something that only a human can do, let's actually talk to a bunch of human experts, right? Let's sit down with them, let's figure out, let's ask them how they do the thing that they are doing, for example, playing chess. And then we will write down whatever they tell you, whatever approaches they follow, we'll just write them down as rules for the computer to follow. And then we will explicitly put these rules into the computer. Okay, so this makes a lot of sense. If you want a computer to do something, let's ask an expert, write it down, program it directly, great, problem solved. Now, the problem is this has very subtle deficiencies, this very commonsensical approach. So to demonstrate what I'm talking about, let's say that we want to get together and build a simple AI system. And what it wants to do is, we'll show it a picture of some furniture, and the system will tell us whether that picture has a chair or a stool or neither of them. Okay, very simple case. So if you follow the traditional approach, how you would actually solve this problem is that you would actually talk to a bunch of people, such as ourselves, because it's a simple problem, and then they'll tell you, basically, if it has 4 legs and a base to sit on, it's probably a chair or a stool. And that's our first version of the AI system, right? Very simple. Now you take the system, you run it on a bunch of images to see how well it does, and then soon enough, you're going to come up with an example like this, where it's clearly a table. However, our system is saying that it's a chair, right? And so, you're obviously disappointed with the performance of your system. It's not very accurate. So you go back to the experts and say, hey, we need to update these rules because it's not good enough. And then the experts tell you, oh, wait a second. Actually, if it has 4 legs and a base and can seat only 1 person, then it's a chair or a stool. That's your second version of your AI system. You start using it. And then soon you run into this problem where you have this image on the left, which clearly Pottery Barn says is actually a table, not a chair. And so it becomes sort of tricky. Okay, is it a chair or a table? And then you go back to your experts and say, okay, what do we do now? And then they tell you, well, if it has 4 legs and a base, can seat a person, and it's not quote unquote too low, then it's a chair or a stool. You get the idea, right? This iterative, ask the experts, find a rule, keep making it better, is just really long, tedious, and error-prone. So for this reason, the traditional approach to AI had success in only a few areas. It did not have the pervasive success that its founders dreamed of. So the question is, why is it so difficult? We do it all so easily. Why is it so difficult to build a system to do this? And turns out the difficulties are very subtle. The first difficulty is actually famously called as Polanyi's paradox. And it goes by, we know more than we can tell, right? So we can do lots of things as human beings. We can do lots of things very, very easily. But if someone asks us, hey, how exactly did you do that? We find it very, very hard to describe exactly how we did them because we do it sort of in a fraction of a second. It just comes easily to us. So that's sort of the first problem. Even if you ask people how they do something, they're unable to actually tell you exactly how they do it. And in fact, sometimes when they do tell you how they do it, they're actually making it up. They don't actually know. The second reason is that, in the real world, to use an AI system in the real world, you have to essentially account for all possible contingencies, right? So, but it's impossible to write down rules to cover every possible situation, every corner case, edge case, and so on. Or to put it differently, we can't generalize to new situations the system hasn't seen before. These are some of the reasons why it's so difficult to build an AI system using the traditional sort of talk to experts, figure out what they do kind of approach. So to address this problem, a different approach was developed. It was a radically different idea. And the idea was actually very simple at its core. Instead of explicitly telling the computer what to do, why don't we just simply show the computer lots of examples of what it should do? So lots of examples of inputs and outputs, lots of pictures of furniture and whether it's a chair or a stool, right? And then we'll just have the computer use some mathematical techniques to learn the relationship between the input and the output automatically, right? Instead of giving it instructions, let's just give it examples, right? That's sort of the fundamental switch. And because, as I think you would all agree, that it's much easier to collect data than to collect understanding or to elicit understanding from a human. This is machine learning. And as you can see in sort of this evolving picture of the ecosystem, AI is this big circle and machine learning is a much smaller circle inside the AI circle. And I depict it this way because you need to remember that there's a lot of stuff in AI that's got nothing to do with machine learning. But as you will soon see, all the excitement we see about AI right now is all coming from something that's not even machine learning, but there's something that's within machine learning. But more to come on that. So this is machine learning. And machine learning has had incredible impact, and it is used worldwide across numerous applications. In the interest of time, I'm not going to go through many of these examples, except to say, credit scoring, loan granting, predicting disease, demand forecasting, the list goes on. There's just numerous examples. Very successful technology. It's very effective in particular when the input data is structured. What I mean by structured is that, imagine data which is sort of very nicely numerical and it's sitting on the rows and columns of a nice spreadsheet. If your input data is like that, it's kind of, if it can live in a spreadsheet, we think of it as structured data. And then for this kinds, if your application involves structured data, machine learning is a fantastic choice. It does a fantastic job. However, the situation is very different if your input data is unstructured. What do I mean by unstructured? Think of images, videos, natural language text, audio signals, MRI, X-ray images, things of that sort, right? This is all unstructured data. And the reason why we think of it as unstructured data is as follows. Let's say that you want to build a system using machine learning that can just look at an image and figure out if the image has a dog or a cat, okay? So going with the whole machine learning sort of learn from example methodology, you painstakingly collect a whole bunch of pictures of dogs and cats, and for each picture, you essentially give it a label which indicates whether it's a dog or a cat. And then you proceed to send these examples to a machine learning system and try to get it to predict something. It will not do very well, unfortunately. It will take this picture of a dog, which by the way happens to be my dog, and then it may predict that the dog is actually a cat, right? It won't do very well. Why does it not do very well? It's because if you look at this picture on the left, which again is my dog when he was a puppy, if you take this picture of the dog, the way this picture is represented digitally in the computer is just by using these tables of numbers. And don't worry about what the tables actually mean, except to say that each picture is just numerous numbers, tons of numbers. And these numbers just measure how bright a particular pixel is at a particular location in the picture. It has no notion of what the underlying object is. It doesn't know it's a dog. It doesn't know it's the eyes of the dog and things like that. So to put it more broadly, the raw data that you see here has no intrinsic meaning. That's the problem. And so typically, if you want to solve such problems with machine learning, what people would normally do is they would actually spend a lot of time and effort manually, and they would convert, these things you see here, these tables of numbers here, and they will convert them into variables or features that have some meaning. So for example, maybe they have a hunch that, if the animal has whiskers, it's a cat. If the animal doesn't have whiskers, it's a dog, right? This is not a perfect predictor, by the way, I know, because some dogs have whiskers, but just go with me on this. So you can imagine creating a new column of variables which indicates whether it's whiskers or no whiskers. And once you laboriously take this data and render it into whisker or no whisker, then it's very easy for machine learning to solve this problem. It'll do a great job. Okay. Now, as you would have suspected already, just means that anytime you wanted to apply machine learning to a problem in which the input data is unstructured, like images and video and so on, a massive amount of human effort is required to first take the unstructured data and then structure it. And because of this massive human bottleneck, right, to make machine learning work in these situations, it sharply limited the reach of machine learning, right? That was the problem. And then another breakthrough happened, and this is deep learning. And as you can see in this evolving picture, deep learning is just actually even within machine learning, it's a particular kind of machine learning, and this is deep learning. Now, deep learning, basically, some of you may have heard the expression neural networks, which is actually an old machine learning technology. But the breakthrough, the deep learning breakthrough, and I'll describe exactly why it's a breakthrough in just a moment, it came because there was a perfect storm of three forces that were once they came together, we would apply them to an old technology, which is neural networks, and that actually was the key deep learning breakthrough. These ideas there were a whole bunch of new math and algorithmic breakthroughs. Number two, there was just unprecedented amounts of data, these input-output examples that we could actually train these models on. And then finally, computing power, particularly the use of something called a graphics processing unit, which was originally invented to make video games run fast. They were repurposed to deep learning. So these three forces came together, applied to neural networks, and that was a deep learning breakthrough. Okay, now what is so special about deep learning? It can handle unstructured input data like images and text and so on as easily as it can handle structured data. That is the breakthrough. So we don't need human beings to sit down and laboriously first work with the unstructured data, transform it into a structured data, and then run it through machine learning. We could work directly with unstructured data. So once we remove this human bottleneck from being able to handle unstructured data, basically just blew the doors off this whole thing, and it just took off. Deep learning can do these things without any upfront manual processing, and that is actually sort of the seminal breakthrough in AI, which actually has made everything possible. And I'll try to explain why this is sort of the seminal breakthrough in the next few minutes. So what deep learning makes possible, right, is the most important question. And what makes possible is that we can automate perceptual tasks. So think about it, right? As human beings, the things we do quickly and effortlessly tend to be perceptual, right? Seeing something, recognizing something, hearing something and figuring out what it is, classifying something. These are all perceptual tasks. And ask yourself, as a human being, when you see something and recognize what it is, what is the input that you're using? You're just using what your eyes can process, right? Basically, it's unstructured data. You're processing images, you're processing basically video, you're processing audio. Right now, as I'm talking, you're processing my video, you're processing the slides, you're processing the audio that I'm talking. These are all just unstructured data inputs coming into you, the human being, and then you're able to do a whole bunch of processing on it, right? So given the input to what human beings do is unstructured data, and given that with deep learning, we are able to now directly work with unstructured data. So this barrier is basically gone. Therefore, and I love this sort of conceptualization of what's possible by Andrew Ng of Stanford. He says, if a typical person can do a mental task with less than 1 second of thought, we can probably automate it using AI, either now or very soon, right? So that's sort of the fundamental thing you need to understand, that deep learning makes processing of unstructured data effortless, right? And that opens the doors to a lot of possibilities. So in particular, what it means that any sensor you can think of, right, that's sensing the world, that's seeing things, hearing things, and so on, you can now imbue it with the ability to understand, recognize, and classify what it's sensing, right? That's the fundamental ability that we have. And so there are examples all around us. So when you're looking at your phone and essentially the camera looks at your face and unlocks the phone for you once it determines it's actually you and not somebody else, well, it is using deep learning to sense what it is seeing and understand what it's seeing. When a self-driving car is going through, driving on a road, it's constantly sending in the video signals and radar signals from what it's seeing, and it's constantly analyzing and classifying, recognizing using deep learning. When we actually send a picture of a mammogram image through a deep learning system, it can very quickly detect whether it has some evidence, of a cancerous growth somewhere. Similarly, you can send an X-ray and you can figure out if it has pneumonia, skin cancer. You can apply it to industrial products to figure out if, as they roll off the assembly line, do they have defects or not. You get the idea. I mean, the possibilities are numerous and staggering, but that's the fundamental unlock of deep learning. So pretty much any application that you have read about, particularly in the mainstream media, probably uses deep learning under the hood. Even though they will call it AI, what's actually going on is deep learning, which, as you know by now, it's just sort of the third little circle within the whole AI circle, right? This is the small little circle, and this circle, the deep learning circle, is the fundamental breakthrough in AI that has really made AI a household name, and why we are in fact gathered here today to talk about it. Okay, so now let's turn our attention to the output. So far, we've been talking about the input, whether it's structured or unstructured. Now let's turn our attention to the output. Now with deep learning, we could predict structured outputs easily. What do I mean by structured? Imagine like predicting a single number. Like, say, for example, somebody applies for a loan and you want to figure out, hey, what's the probability that they're actually going to repay the loan? That's a single number. It's a probability, right? We can easily do that with deep learning. Or maybe we want to predict a few different numbers. So for example, we want to predict for a particular ride share or a taxi, where is it likely to end up, say 10 minutes from now? We can just look at the GPS coordinates, which is just a couple of numbers. So a single number, a few numbers, no problem. We can easily do it with traditional deep learning. However, we could not generate unstructured output all that easily. We could take an image and figure out what it has, but we could not actually create the image, generate the image in the first place. We couldn't generate human sounding text. We couldn't generate audio signals and so on. And as you would have expected, by now, generative AI happened. And what generative AI makes possible is that it actually can produce unstructured output. Not only can it handle unstructured input, but it can actually produce unstructured output, the kind of outputs that traditionally only humans have been sort of fluently able to do. So for instance, using generative AI, you can go from image, you can give it an image and it'll give you a nice piece of text that describes that image. You can give it a text and you can send it through a generative AI system. It can produce a beautiful picture of that image, of whatever the text describes. And some of you may have used these tools called Stable Diffusion and Midjourney and so on and so forth. So you know what I'm talking about. And the important thing is to understand here is that the description, the input text that goes into these things, the image may have never been seen anywhere before, right? So it's not based on the data it was trained on. It's entirely new things it's able to create. And text to music, you give it a little description of the kind of music you want, it can give you music. So, and of course, the last but certainly not the least, ChatGPT, or as I refer to them as large language models or ChatGPT sort of interchangeably, but the idea of send text in and get text out, right? Which is sort of the most simple thing you can imagine, text in, text out, and that is something that many of us are familiar with. And so it's all part of generative AI. So to step back and look at the big picture here, in the overall landscape, we started with AI, and then we looked at a small piece of AI called machine learning, and then we looked at a smaller piece of it called deep learning. And within deep learning, there's generative AI. And within generative AI, there are many circles. One such circle is this thing called a large language model, which is essentially describes algorithms, AI systems that can actually take text in and put text out. right? ChatGPT perhaps is the most famous example algorithm from within the LLM circle, but this is sort of the overall picture of what's going on. So whenever people talk about AI, they actually are referring to something like ChatGPT, but this is the actual picture of what's actually going on. So I would encourage you to sort of essentially memorize this picture because it's very handy. Okay, now when you ask an LLM like ChatGPT something, how exactly does it generate an answer? It's worth knowing how it actually does this because when you use ChatGPT, having this understanding certainly helps you sort of steer it in the right direction and not get fooled very easily. So as you know by now, ChatGPT is a deep learning model, and it was trained on roughly 30 billion sentences extracted from the internet and from various books. And it was trained to do just one thing, but to do that one thing really, really well. What it was trained to do was we would give it a fragment of a sentence, a part of a sentence, like the cat sat on the, and then we would ask it to predict the word that follows it. So for example, if we give it the cat sat on the, it has to predict Matt. If we give it elementary, my dear, it needs to produce Watson. You get the idea. Now, initially, when you're training this thing, it's going to produce some garbage. When you say the cat sat on the, it might come back and say spaceship. And then you essentially sort of do the mathematical equivalent of wrapping it on the knuckles and saying, bad model. And then over many, many iterations of this process, it actually begins to get it remarkably right. So that's basically what it's trying to do. It's trying to predict the next word in the sentence. Now, once you've finished training this on these billions of sentences, ChatGPT can do something super useful. So you give it any sentence. Let's again go to the same sentence we had before, the cat sat on the. And when you give it, what actually happens under the hood is that it actually calculates this table. You don't see this table when you work with it, but under the hood, it's actually calculating this table. Now, what does this table have? So for each word in the dictionary, you can imagine for each word in the dictionary, there is a row in this table, all the way from aardvark to zebra. And by the way, just a quick technical aside, it uses something called tokens, not words, but I think using words to understand it is actually good enough for practical use. I'm just going to go with that. So each row is a word from aardvark all the way to zebra. And then this is the most important thing, the second column. And the second column tells you roughly what % of the time that word actually follows the input phrase. So for example, here, what it says is that, whenever across all the data it has seen, whenever the phrase was the cat sat on the word Matt showed up, say, 20% of the time. Okay, and it's sort of intuitive. You would expect Matt to show up pretty often. But it says also, the word fridge shows up 5% of the time, maybe. And in case you're dubious as to why cats would sit on the fridges, I actually have some empirical proof right here, thanks to my daughter, who has sent me this picture. Yes, cats do sit on fridges, and so it's not unreasonable to expect that. Now, with this table, ChatGPT can auto-complete the next word for any input sentence, right? So if you give it the sentence the cat sat on the, sure, it can pick the most likely word, which is Matt in this case, and just output that, right? It's the most possible word, but you don't have to go with the most possible word. You can actually just sample the next word from this table. And the idea of sampling is that just go in there as if you're sort of, tossing a coin or rolling a die, and then just grab a word from this table in proportion to how frequently it appears. So for example, the word fridge will show up pretty often. The word Matt will show up very often. Fridge should show up somewhat often, but not as often as Matt, and so on and so forth. Aardvark will probably never show up, and zebra will probably never show up, right? So each time and this is why every time ChatGPT samples something, we may actually get a different word, even though the input phrase is actually the same. And so more believable words will be sampled more often. And so this is one reason, by the way, when you ask ChatGPT a question right now and then say 5 minutes later, it actually may give you different answers. It's because of the sampling that's going on under the hood from this table. Just remember that. And so we have seen now how ChatGPT can generate the next word. We can easily take this capability and make it generate entire paragraphs, heck, entire books if you want. So let's say we ask it, and I'll use the Gettysburg Address. So we give it the 4 score and 7, right? Let's say that's the starting prompt. ChatGPT calculates the table and chooses the next word. Let's say it chooses the word ears, okay? And this is the key trick that comes next. What it now does is it takes what it generated, the word ears, then it attaches it, it appends it to the original sentence you started out with, so that now the original sentence is 4 score and 7 ears. Now it's just a sentence like any other sentence. You just feed it back into ChatGPT. ChatGPT gives you the next word, which let's say is ago, and then you repeat this again. You append that to the input, and you keep on doing it for a while, right? You get the idea. And when you're done, you have gone from 4-7, which is the thing that you started out with, to an entire paragraph of text, right? By repeatedly predicting the next word. So this is the fundamental operation that goes on when you ask ChatGPT a question. Remember, when you ask a question, this loop of, generate the table, sample a word, attach the word to the sentence, generate the next table. This may run thousands of times before the answer pops out. Okay, now what does GPT stand for? It stands for Generative Pre-trained Transformer. Generative because it can generate the next word, pre-trained because it is trained previously on those 30 billion sentences I referred to, and then finally, because the particular kind of deep learning that it uses a particular technical architecture called the transformer, hence it's called GPT. Okay, now I just scratched the surface of how it was built in these few minutes. I have a couple of explainers up on LinkedIn. If you're curious, you can check it out to get a more detailed understanding of how these things actually work. Okay, now let's take a step back, right? We have basically described a way in which you can take text in and produce text out. On the surface, it doesn't look all that impressive, right? So the question is, why is there so much hype and excitement about ChatGPT and Bing and Bing GPT and so on and so forth, or more generally about large language models and generative AI? Why is there so much excitement? Well, it turns out this simple capability of going from text in to text out covers just a vast range of applications. So for instance, let's say you want to summarize text, right? You can, and you have, I'm sure you've seen this already in your personal use of ChatGPT perhaps. You can actually you can feed it a big essay and say, hey, summarize the essay for me into bullet points or abstracts or titles. This is just an example of what's called text summarization. A long piece of text goes in, a short piece of text comes out, very easy. Or let's say that you give it a little prompt like, write me an essay about, blah, blah, blah. It can write a nice 2-page essay for you, right? And that's again, a small piece of text in, a large piece of text out, but fundamentally text in, text out. People are using it for writing marketing copy, sales emails, market reports, social media posts, and more troublingly, college application essays, and so on and so forth. And then it can use to be generate code. So you give it a bit of text to actually give you some code, some programs that you can run on the computer, right? Code written in languages like Python and so on and so forth. And why is that? Because programming languages are just languages, they're just text, right? So it's again, text in, text out. The list goes on. And let me just do one example, which is that you can actually ask it a question. You can also feed it a whole bunch of text from your own documents, and you can have it answer your question from your documents rather than the 30 billion sentences on which it is trained, right? And this, by the way, forms the foundation for a whole bunch of chatbots that people are building these days. Now, this is why, because of the vast range of applicability of this very simple looking thing, this is why McKinsey predicts that generative AI broadly will add, several $1 trillion of economic value on top of traditional machine learning and deep learning. Okay. Now, when you see this thing, you can't help but ask yourself, okay, this looks a lot like what we do as knowledge workers, right? What do we do as knowledge workers? We go from text to text. We look at an email, we respond to the email. We listen to a phone call and we respond to the phone call. We look at a report and then we summarize it, we analyze it, and so on and so forth. This really feels a lot like text to text, right? This really feels a lot like what an LLM could do. And in fact, yes, current technologies, again, according to McKinsey, have the potential to automate up to 70% of what people do, what knowledge workers do, right? Now, if many tasks can be partially or fully automated using technologies like ChatGPT, what happens next, right? It's a thought on a lot of people's minds. And there is no easy answer to this question, but I would like to encourage you to think about a few different things that can happen. The first one, of course, is that, you can think of this technology as a way in which to generate knowledge output, knowledge work output more cheaply than you could do before. Just think about it that way. And from that perspective, a manager could decide that they just want to maintain the current level of output of their team, but by using these technologies, they can do so with fewer people, right? It's the most obvious example. And if that happens, there will be job losses, right? Number one. But management decide that they would want to use the extra capacity that's being freed up by the use of these tools, and then with the same people they currently have, they might want to increase the output, or they may want to pursue new opportunities that they previously could not conceive of. If that happens, the current job roles will not only be preserved, but they'll actually expand. Right? Roles will expand. And we have seen this happen historically when new technologies were introduced into various sectors. Now, when this happens, if you go after a new opportunity, it's going to increase hiring for complementary jobs, right? Other jobs that get sort of pulled along for the ride, right? There might be increased hiring there. And of course, entirely new jobs are going to be created as well. So there is in fact already a job called prompt engineer. You can just Google it, prompt engineer. It's a new job that didn't exist probably 2 years ago even. It exists now. And that's for figuring out how to best work with tools like ChatGPT to get the things that you want, to get the outputs that you want. So you can see there are going to be some losses, there are going to be some gains, and it's very difficult to predict ahead of time how it all is going to net out and how it's all going to net out now in the medium term and in the long term. So I want to start wrapping up with sort of a few quick guidelines for how to safely use large language models. As you folks know from personal experience, ChatGPT can do amazing things. I found it particularly shocking that it could actually write entire Seinfeld episodes, but it can get simple things wrong. So for example, if you ask ChatGPT this very innocent looking question, which is what is the fifth word of this sentence, right? So let's count. What is the fifth word? So the word is the fifth word, right? That's the right answer, but it'll give you something else. It might actually give you the word is, right? So it can get simple things wrong. It looks like it can't count all that easily, even though it can do amazing things. It also will make stuff up all the time. Experts in the field call it hallucination. I just like to call it makes stuff up, right? Let's be very clear about what's going on. So for instance, sometime recently, I went into ChatGPT and say, hey, list all the awards that I have won. And it came back with this list. And I was looking at it and I was like, wow, I want to meet this guy. He sounds amazing. The only problem is none of this is true. I have not won any of those awards, okay? So it'll make stuff up all the time. So more generally, LLMs generate problematic output, and the problematic nature of the output could be manifold. It could just be inaccurate, like you saw in the what is the fifth word example. It could be irrelevant, it could be offensive, it could be harmful, it could be the wrong tone or vibe. It may actually use somebody else's copyright protected data. The list goes on. So I have to be super careful on how you use these things, right? So is that a simple way we can think about how to safely use a technology like this? This was a flow chart that I saw on UNESCO.org, which I thought was really well conceived and very sensible. And it basically says, look, start. Does it really matter if the output is true or not? And if it doesn't matter, go ahead and use these tools like ChatGPT. Now you might ask, okay, when does it not matter if the output is true? Well, for any sort of creative pursuits, right? You're trying to get some help writing a script for a film or a play, or if you want to do a brainstorming session, there is no sort of true or false. You just want to get some creative ideas to get the creative juices flowing. You can totally use ChatGPT safely, no problem. However, if it does matter, if the output needs to be true, right? You can imagine a medical decision-making scenario. It does matter the output is true. Then the thing you have to ask yourself is, do you have the expertise to verify that the output is actually accurate? And if you have the expertise, yes. If you don't have the expertise, don't use it. It's dangerous. But if you do have the expertise, are you willing to take responsibility when, despite your best efforts at checking the output, you let something out and it turns out to be wrong? And if you're willing to take responsibility, yeah, I think maybe you should sort of consider using ChatGPT. I like this framework, but I think it's missing something, so I added something here. So not only do you need to have the expertise to verify that the output is accurate, it also needs to be doable cheaply enough for you, right? If it takes a long time for you to verify the accurate, you may as well just do it yourself. Right? You don't have to use ChatGPT. So to put it all together, this suggests a particular sort of a sweet spot for using large language models with current technology. So I would encourage you to consider using these models like ChatGPT for tasks where the so you just have it created for you, and then you check and fix errors in the output. If the cost and time involved in doing so is vastly less than for you to actually do it from scratch, right? If that is true, and if the cost of a miss is okay, is tolerable for you, then consider using it. And in case you're wondering, these are some examples of such tasks. Writing simple programs, creative artistic work, generating content for various sort of use cases like marketing copy, sales copy, ad copy, and so on and so forth. There are a whole bunch of these examples that people are already experimenting these tools with. Okay, so in closing, I want to say that I really scratched the surface here. I didn't have time to cover a lot of topics, so feel free to ask in the Q&A if you're interested. Things like, how do I personally get better using these tools? How can my organization start experimenting? what are large companies doing? What are entrepreneurs doing? What are the risks to society, and so on and so forth. We didn't have a chance to talk about it in depth, but I do want to say that it's a very powerful technology. I've been in the tech industry for a long time, and I think this perhaps is the most seminal breakthrough that I have seen in my sort of working life. It's got huge potential for the betterment of society. And just to take one example, which is from medicine, I would actually encourage you to check this book out. It just came out recently on sort of the vision for how these technologies like GPT-4 and beyond will likely lead to a revolution in medicine. And if even 10 or 20% of what they prognosticate actually comes true, it's going to be amazing for us. And it's only just for medicine, this example, and you can actually apply it for lots of different things, such as tackling climate change and so on and so forth. So it has lots of benefits. However, it comes with significant risks. It's going to amplify misinformation, amplify bias and toxicity. It's going to probably aggravate inequality. It's going to lead to some job losses. It's going to lead to increased cybercrime, societal stress. I mean, the list goes on. So what that means is that it's important for all of us to understand this technology and engage with it so that we can collectively sort of steer it the right way. So finally, in closing, I want to say that I strongly recommend investing some time and your curiosity, more importantly, in sort of experimenting with tools like ChatGPT and Bard and so on, other tools like that, and develop sort of this visceral understanding of how to use them. Because what I've seen personally is that knowing how it works intellectually is one thing, but actually working with it on a day-to-day basis, experimenting with it, playing with it, gives you a level of understanding of how these things work that's sort of very difficult to obtain in any other manner. So I sort of encourage you to roll up your sleeves and actually work with them, because they do fundamentally believe that in this very uncertain future that's coming upon us, those of us who are actually sort of who have worked with these tools and who understand how they work, who understand how to harness them for good use, I think are better prepared for the uncertain future than folks who are sort of recoiling from it or staying away from it. So I encourage you to sort of embrace them and play with them and see what they can do for you. Thank you. So I'm done.
Thank you so much, Dr. Ramakrishnan. That was extremely useful and so much of information that I'm sure everybody is hearing for the first time. And there are a lot of questions I see on the chat box, so I'm gonna get them to you, I hope, at the end of after Ms. Satyam's conversation next. So that was extremely educational, wealth of knowledge on how technology, how it really works. And also, I believe that how it's important for technologists to be at the table of decision making on various sectors of society, including policy, including mandates, including frameworks, compliance, regulation, and ethics of the use of this technology, and also a better understanding clearly. So with this, I would like to turn the conversation on to Ms. Nishtha Satyam. She is the head of UN Women, again, Timor-Leste, and she is. We'd like to hear from her on how the social sector is actually adopting to these new technologies and how these biases are being addressed. What are they really doing and how they're going about doing it, and what are the challenges they're seeing in the process. Ms. Satyam, it's such a pleasure to have you here. The floor is yours.
Thank you for the informative education, Dr. Rama. It's too late for me to change my major to technologies and AI, but certainly it's not too late to utilize AI, right, in our field of tax and advisory, or maybe many other aspects, sectors. So coming to that, how's AI being adopted in the social sector? As Suma mentioned, what are the challenges? Is there a digital gender divide that needs to be addressed? So we would like to introduce you to our next speakers, Ms. Nishtha Satyam, who is the head of UN Women, Timor-Leste, who will talk to us about this important subject. UN Women is the entity of the United Nations that is dedicated to working towards gender equity and women's empowerment. Ms. Satyam was appointed in her current position in September 2021. She was the former deputy country representative for UN Women in India and served as officer in charge. As the youngest woman to head a country officer for UN Women, Ms. Satyam is an unapologetic feminist, a trained economist with a keen interest in applied macroeconomic and fiscal policy. Prior to her long-standing career with the UN, Ms. Satyam worked with the leading firms such as KPMG and American Express as an economist. As a futurist, she is a loud advocate of the urgency to mainstream women across the marketplace, workplace, and the community. She also served on several national and international committees, including the Advisory Board on Programming on Artificial Intelligence of Global Policy Insights and the National Committee to Review Gender Budgeting. So Ms. Satyam, thank you for joining us today for this fascinating and important topic. Very nice meeting you. So with the AI now increasingly being used everywhere across various stages of the policy cycle, from agenda setting to policy formulation, decision making, implementation, and evaluation, the concept of fairness, justice, and equity appears to be as important as the benefits that AI can bring to the society. So please share with us your perspectives on how social change is keeping up with the speed of innovation in AI and frontier technologies, and the impact on the digital gender divide, and how you are working with these challenges. Thank you for your time. Sorry, Mr. Dana. So please are you with us your perspective on how social change is keeping up with the speed of innovation in AI and frontier technologies, and the impact on.
Well, thank you very much. I have a bit of a lag in hearing you all because there's a big storm of here today, which is completely rocked connectivity. And so probably I'm just running, I hear a bit, because I could hear all three of you speak at the same time. So I think that's pretty ironic that we're having a conversation on technology while I'm struggling to connect with the internet. And probably that's where the expose is. And so probably I'm just running. I can hear myself now. But I have a few confessions to make before we really. Suma's showing me her finger, so I'm not too sure if any of you can actually tell me if you can hear me well. Okay, you can hear me well. That works. So I have a couple of confessions to make. One, that I'm not an AI insider. I'm a total AI outsider. There's very, very little that I understand about this, but of course we understand the gender divide much more. Probably if you can hear me well. And the other is a confession too, is one that I love ChatGPT, though I don't understand it at all. The two things that Dr. Ramakrishnan put on a slide: one, it explains jokes. It just clearly points to my average intelligence too, because it gives me words that I don't have, both of which are beautiful additions to my life. And the third is that my father has the ability to write an entire note on gender and send it to me. And when I ask him how, he says ChatGPT. So it's quite very threatening to be replaced. I don't understand it at all. Really with knowledge. But it truly is a discussion that we should have, and I'm glad that we are really bringing the nexus of gender and technology. It's not very talked about. But what we has the ability to write an entire note. What we know for sure is if we do things wrong, it has the ability to reverse the change that we have made in certain aspects like race, gender, inclusion, sexuality by decades. And we know that the one thing is, and Dr. Ramakrishnan really put it so well, how it works under the hood. And it's true that it actually does work under the hood. And that's and that's probably where we must roll up our sleeves, like he said. But what we know about gender is that we know lesser and we tell even lesser. That the one thing is that the structured data or everything that we know about the world is a default male setting. And it's not male setting from a global south. It's not male setting from the rest of the world. We know that it is dominated by the experiences of what we may say, white men. And we have some great examples on what that data set looks like. So going back to the input-output conversation, I think we've spoken a lot about the output, but where we see the gender problem is the input itself, is that women are most invisible in data sets. And as long as we're writing social media posts using that data set, it's fine. But the moment we start programming policy for change, it probably is going to lead us down a path where we know very little of how women's experiences are unique, are different. And what we know is when jobs are lesser, when there is misinformation, women are disproportionately impacted because women already experience very, very vulnerable lives, lesser access to data, less orientation to technology. And we see that across all levels. Just to give you a small example, because Dr. Ramakrishnan used the predictive word, and going back to that sentence at ChatGPT, you see that when you run it 7 times, it goes slowly from 7 years ago, our father, and then goes to our father created. And most times, just that misses the entire contribution of what women have done. Women have been very anonymous in the inventing space. And what technology does is it normalizes that at a point when we believe that the chorus for gender equality is rising. We finally believe that I wouldn't say our time has come, but we finally do believe that we're at a point where we can either miss gender equality completely or probably achieve it. But if all governments, and sorry, because I work for an intergovernmental agency, and I'm also paid to put the gender perspective forward, if none of us do anything different on the data sets that we have, we are probably going to achieve gender equality only by 2089. The goals that the world has set for itself is 2030. So we're probably running 50 years behind. In what our own ambitions as governments, in our own ambitions as people, as countries are. And the gender divide is pretty, with technology almost emerging as a normative power. Probably going to achieve gender equality only by 2089. The goals that the world has set for itself. I can see Suma pointing a finger. So probably running 50 years.
Your voice is resounding. You want to turn down your speaker or something because you're resounding. Yeah,
I'm resounding. I don't know how
you're resounding.
Well, I think any conversation on gender should be resounding is the only way to make it.
So we are hearing.
The goals that the world has set for itself. I can see someone pointing a finger. So
your voice is resounding. You want to turn down.
Well, I don't know what to turn down because I'm not logged in from any other account. I don't know if someone's not on mute. So if I don't know what exactly I must turn down for it to not resound.
Hearing.
The goals that the world has set for itself. I can see someone pointing a finger.
Your voice.
I'm going to try and switch off my webcam if that helps because we're so low on bandwidth in the country. Maybe that helps. Okay. Not really. I can hear Dr. Ramakrishnan nodding, so I probably believe that. Okay, I'm not too sure if this is better, but if someone can tell me if it's no longer a problem because I can see all of you. Suma, is that better? Okay. I'm going to be quick because technology really is the problem here. But what we see is the predictive nature of technology is to predict what we know. And coming back to what we know that bias reproduction particularly with tools like ChatGPT at a large scale, is a problem, could be a problem. We know that large companies, and Amazon has a great example that it put out itself. I'm going to be quick because technology is a problem. Yeah. That a recruitment algorithm that was developed by Amazon to sort resumes for application had a very, very simple bias. It kind of downgraded everything that had the word women, including references to those who were from women's colleges. And we know that it was trained on historical data and the preferential recruitment of men. And it ultimately could not be fixed and had to be dropped. And we have so many examples like that. If you just run a simple Google search which says man, computer, programmer, woman, X, it says home X, it would be homemaker. Had a very, very simple bias. Or if you put the Hungarian sentence, which is actually a very gender neutral sentence, which says it translates, which is no gender, and had to be dropped. Which says so many. She is the doctor, she is a nurse. It actually assumes in its translation the gender, and it says father to doctor, mother to nurse. Programmer, woman, X. It says home X would be homemaker. Very, very simple. And so what we know for sure is that there is a tremendous data gap in how women's lives play out differently, in how women belong to leadership, in how policies affect women differently, in how women have very, very differential lived experiences. We also know that most of technology does not play out the same between developing countries and developed countries. We're still representing the experiences of the Western world to a large extent, and therefore the diversity of leadership in technology is absolutely important, so that we don't code and compound the bias. And like I said, bias reproduction, misinformation. Also, I'm a hobbyist researcher, and the one thing we know about hobbyist researchers is the whole possibility of propagating the confirmation bias. We search for what we think is true. We search for confirmation, and we know that it hasn't worked for women all through. I'm a hobbyist researcher, and of course, particularly when you ask me about how the UN's dealing with it at the time when we are looking at development problems, we're looking at skilling, we're still working. We search for what we think is true. We search for where we're trying to really build skill, particularly talking to you from a country that is the youngest democracy in the world. 75% of this country is young, between 25 to 35. It's a post-conflict economy. It's a fuel economy at a point when we are dealing with very, very basic problems. We see the advent of technology, where we're almost ready to replace people. And so it poses a very different kind of problem for organizations like the UN, but like Dr. Ramakrishnan said, we must roll up our sleeves. I think we have a choice to deal with AI or to not deal with AI. But we must.
I'm so sorry to interrupt. We're all having trouble trying to hear you. I would recommend turning off the speakers on your computer device. Hopefully that will help. I apologize to everyone who is experiencing echo and feedback on their end. Hopefully we can resolve this issue shortly. So hopefully just turning off the speakers on your computer device, hopefully that can help your...
My speakers are off. Can you still hear me?
We can...
Is it better? Is this working better?
Yes. If everyone can give a thumbs up. If she can't hear us, maybe she can hear a thumbs up.
Sorry, we have a very, very bad connectivity here because of the weather and also a bit of a quake. But just to summarize what I said, what I was saying, gender is probably one area of work where we know less and we tell lesser. And that's a fundamental problem in how policies are made, in how we appeal to women. And so most of the times we do end up propagating the gender bias. And we know those from examples across the world, from how we recruit, who we promote, who we recognize as leaders. And like I said, I don't know if I was clear enough in my previous examples, but we know from big corporations setting up recruitment algorithms that have downgraded resumes that even had a reference to women or women's colleges. But we also know at the same time, AI is emerging as the health warrior. Dr. Ramakrishnan gave us the example of mammographies, and we know that from a recent experiment in Sweden, it kind of brought down the workload of doctors and nurses in detection of breast cancer by almost 44% without actually propagating the possibility of a false positive. And so there's immense possibility in health. AI is now emerging as the new climate warrior for countries like us that are very, very high on the disaster zone, where the vulnerability of people to climate is extreme. AI represents a huge possibility of recurring costs of governments, of coming back. COVID-19 is a great example of how AI can be used. But what we know is that the quality of that input, it has to be upgraded. The experiences of women, their lived realities, the differences in gender have to be incorporated, particularly when it comes to bias and stereotypes. We know that that AI has the possibility to propagate stereotypes. And it is something that the world has worked on for centuries. And today we stand at a point where we possibly could reverse, particularly through large-scale programs, through larger avenues like ChatGPT. There is a possibility that we could reverse the work, but there is also a possibility of furthering the progress that we have made, the compounding the progress that the world has made. But what it totally needs is to be responsible at this point. And responsibility to me is based on two big things. One, of course, is intentionality, is that we want to be responsible about it, is that we want to be responsible, we want to be intentional as policymakers, but also as people who represent the technology world. To not propagate the bias. Like I said, I was saying that I'm a hobbyist researcher, and the one thing that we know from hobbyist researchers is the confirmation bias, is that we look for things that we believe in. We believe in things that we love a confirmation. And we know that the world works in ways like that. And that in itself has the possibility to propagate bias. There was a very interesting research done in Brazil by a university, just with the keywords beautiful and ugly and women across 59 different countries. And it isn't surprising that all the images that it categorized as beautiful were women who tended to be younger, who tended to be white, while the ugly kind of returned images of older Asian women. And we know that algorithms do determine what internet users see in research results. And that example can be applied, like I said, to recruitment, to so many other spaces. I was earlier giving the example of just a simple search term which says father, doctor, mother, X, and it says, and where X is mostly the nurse. And the same research query which says man, computer, programmer, woman, X, it prompts women as the homemaker. So of course, prompt and to predict the next word. Just also picking from his slide itself is when it says, the whole image of our ancestors is purely male, where we know that the design world is purely male. From basic design things like phones are not made for women. When COVID-19 hit, despite the fact that a large percentage of the health workers across the world are women, the first PPE kit that was made during COVID-19 was not made with the woman in mind. Women actually had to fold PPE kits to wear them because it was not built for women. And that in itself shows which kind of really defeated the whole purpose of a PPE kit. But we know that we don't take into account that women represent a large part of informal sector workers across the world. Women represent very influential decision makers inside the household. but also ways in which women hold half the sky, but don't reflect on big databases. And using that database to make and predict literally our own reality to come probably needs, like I said, two things. The lens of intentionality, which is we must be intentional about the change, and intersectionality is where we produce things that are also relevant for the experiences and the lived lives of the rest of the world. We know that still in many ways the default setting is the Western male, and I think it's time and probably to invest both for organizations, world organizations like the UN, we have the private sector, we have academia, to invest really in a global AI observatory space to see and to bring the collective wisdom of our worlds together. And truly, like Dr. Ramakrishnan said, we must roll up our sleeves, but how quickly we roll up our sleeves is probably going to determine the world for women, particularly for all the work that feminists have done for a very, very long time. So I'm going to stop there and then bring in more data in how things work very differently. We have some interesting examples that I would love to share as we go forward.
Well, thank you to both of, sorry, now I have some problem with my connection. Thank you to both of our amazing speakers sharing your perspective. I certainly enjoyed, I learned a lot, and look forward to meeting you, both of you in person. So now, Suma Chander, our practice leader of technology, who has a significant experience in helping clients build a technology platforms to moderate the Q&As. Suma, please take it from here. Thank you.
Thank you so much, Nishtha. That was just a very, it resounded a lot with basically a lot of what we did on the W20 task force in terms of understanding the challenges that specifically around the digital gender divide, and Dr. Ramakrishnan for your insightful, deeper understanding on how artificial intelligence is and where it's growing and how it's growing really. So I would like to, I see a lot of questions from the audience, so I'll keep our questions to the minimal and try to address as many as possible on the chat. Some of the key things that we wanted to ask you both is, Dr. Ramakrishnan, one of the things that we wanted to understand from you is what and how do we look at the key challenges for business owners and organizations in terms of incorporating and including the social sector, like Nishtha is saying, was talking about incorporating artificial intelligence into the mainstream. Like, how do you go about doing it? What should you be really looking at? There's a lot of hype. There's a lack of understanding and lack of, I really believe, real technical understanding and right people sitting at the right place.
Yeah, I think I will speak to perhaps the for-profit sector, and I will defer to Nishtha on perhaps on the social sector, if that's okay. So, from my perspective, I think what people should do, these are my recommendations typically to companies when I talk to them, is I don't think sitting on the sidelines and waiting for the dust to settle is actually an option. I think it's actually dangerous. I think you need to actually start doing something. The question, of course, is what is that something? And I think that it is possible to very judiciously conduct experiments in a safe and sort of a unrisky way. So here are a few examples. If your organization employs software engineers, I think at this point it's sort of a no-brainer that using these tools like ChatGPT to in the process of developing software is actually a huge accelerator. A lot of cutting-edge teams are routinely using these tools to really improve their productivity. So if your teams are not doing it and the competition is, you are in fact running at a severe disadvantage right now. So I would say that's almost like sort of the 0th item on the list because it's such a sort of a no-brainer. You have to do it. The second thing I would say is that if you go back to my little framework about what is a sweet spot for using these technologies, I think you should look at tasks that people do. Actually, before I go there, I think looking at jobs is too big and monolithic. I don't think it makes sense because each of our jobs is made up of a whole bunch of smaller tasks. I think it's much better to have the task lens rather than a job lens. So look at each task that we do, and then ask ourselves, is it possible that we can at least partially automate it using ChatGPT and tools like that? And I think the key thing is to make sure that if the cost of having ChatGPT do it, and then you just check the output and fix the output, if that cost is a lot less than you doing it everything in the first place, and if you're okay with the occasional miss, right? Despite your best efforts, you may not be able to make sure everything's fine. And if you can tolerate the cost, which could be equity, capital, it could be a whole number of different dimensions, but if you can tolerate that, then I think you should experiment with it. And which is why people are experimenting with these techniques for things like sales, copy generation, marketing, content generation, things like that. But I think the big caveat there is there has to be a human in the loop. You have to make sure that these things are not used in some sort of automated, sort of lights out fashion, where you feed something to it, it generates some content, and then it goes out into the world for your customers and partners and other stakeholders to see it. Super dangerous. There has to be a human in the loop. So I think these are all some things in which people can start running experiments and taking some sort of baby steps and dip their toes in the water. The one other thing I would say is that a lot of things that people are, particularly vendors, are calling AI is actually not AI. It tends to be traditional machine learning. But of course, since AI is now very popular, everything is everybody is stacked on the word AI to what they do. And the traditional machine learning is actually very powerful. It's very pervasive. It's already heavily used. So figuring out, is it traditional machine learning or is it sort of the new generative AI stuff? That almost, in fact, is the first decision, I would say. Figure out which one it is. If it is traditional machine learning, there is a very well-established body of knowledge as to how best to use these systems and how best to use them in applications and in a safe, impactful manner. So you should just piggyback on it rather than try to reinvent the wheel. But if it's the new thing, like generative AI and ChatGPT and so on and so forth, the comments I said earlier about careful experimentation are the ones that become applicable in that context.
Ms. Nishtha, we would look to you for your input on in the social sector.
Suma, thank you. It's actually wonderful to hear all of you. I think particularly, and this is probably more relevant for organizations like the UN, is we must start with not demonizing AI because it really presents the possibility of very, very transformative change. Changes that governments have not been able to make, changes that we're still strictly struggling with, goals that are ambitious and lofty. It actually gives us the potential, particularly to solve large problems for particularly the developing world on education, on health. And like I said, we must start with intentionality. And the one thing that is probably the need of the hour is the need for collective wisdom of all our worlds, is the need for the world organizations, for universities, for leaders that understand this a lot more, for private companies, advisory companies like yours to come together. And the fact that we're having this conversation and we are demystifying AI, because people like us who are working on the policy side don't necessarily understand AI. What we understand is the risks that it poses. But we begin to talk about the risks without exploring the opportunities that it presents. And I think this has happened too many times with those who are leading change on a policy front. And this is an opportunity that we do not want to miss. But the beginning of it is to demystify it, is to speak to people and for different worlds who understand this differently to come together. And I think conversations like these, this falls into the category of an educational conversation to me, and where we are able to bring our realities together. And particularly in data, we've just begun across the world to bring in sex disaggregated data in large data exercises like the census. And so for us who are working on the other side, this conversation is so much ahead of us. But it's true that this will happen with or without us. And we'd rather, as the UN, prefer that this happens with us. But I think this is also a moment for us, for larger organizations, particularly those who work on very basic problems, to reach out to a world that understands it more. And we take that as our responsibility, and and this is probably a moment for us to call for help. But for me, the two things to begin with is also to balance representation in the design of AI technologies. That is, the beginning is to bring more women into decision making. And I think those are very, very good starting points. And we know from the history of other things that it works. It works to have balanced representation. If we target, it's probably a very top-down approach, but it's a good starting point to begin with, because these are things we can put our hands on. We know that only 18% of leaders or those with decision-making are women among top AI startups around the globe. We know this is things we know where women are not well represented, and these are things that we can bring advocacy, advisory, and expertise together, and that probably is a very, very good starting point for us to start beginning the change. Like I said, this will happen with or without us, and we must find ways to do this together.
Thank you so much, Nishtha. Absolutely. It's true that also there's a lack of women technologists at the table in most companies. I think Dr. Ramakrishnan would agree. There are very few women in the leadership positions, in executive leadership positions, in design positions, and actually working with these innovative technologies and frontier technologies. I think that is also could be a part of the problem, and I think needs to be addressed. That was a part of the W20 conversation as well. The next question I'd like to kind of take both of your take on is, there was a recent commitment by leading technology companies, the big tech companies, along with the White House, to work on regulation, transparency, and disclosures around what artificial intelligence is generating versus not. How do you see this being implemented? Is this even possible? What we see is there's a lack of technologists, period, in policymaking, like Nishtha has mentioned. So how do you see this working, Dr. Ramakrishnan, and you also, Nishtha?
You know, I mean, I welcome what came out, the announcement that came out. That said, you know, it's a bit of a, so my concern is that it actually lacks teeth. There are lots of well-intentioned pronouncements that form what was said. They are certainly well-intentioned. I think, you know, people in the field will agree that these are all good things to do, if only we could make sure that the companies involved would actually do them. And so the question becomes, if it's sort of a voluntary thing for the companies to adhere to these guidelines, how do we actually make sure they adhere to them? It's not clear from looking at all the guidelines, with one exception. And so one of the guidelines was that AI-generated content should be clearly designated as such, so that, you know, the possibility of, you know, misinformation, deep fakes, and things like that hopefully will get reduced. So there, I think we can actually, there is a way in which, you know, if companies, we can track to see if these companies are over time, you know, what % of their content is actually, you know, what they call watermarked or designated as, you know, being generated by AI. We can actually measure how well they're doing it. Right, and so in the big companies clearly have the talent to do it. They have the technology, they have the capital to do these things, and so so you can do it if you wanted to. So are you doing it? And we can actually measure if they're doing it or not. So that one example of, you know, the trackability and the monitorability of AI-generated content, I think, is one good thing. The other things are also good, but it's not clear to me how one might actually make sure people actually follow these guidelines, because these are not, you know, enforceable commitments per se. These are just voluntary guidelines that the companies have, you know, basically said, yep, I'll do that. But whether they'll do it under the pressure of market forces, competitive forces, P&L forces, Wall Street forces, you know, it remains to be seen.
Satyam?
Voluntary guidelines that the companies have, you know, basically said, yeah, I'll do that.
Thanks, Suma. Sorry, there's a bit of a lag, so probably that's why I took a minute to realize that the question was to me. Well, the lack of transparency in AI systems, or really the black box of AI systems, is probably well known, and we must work towards ignored being a black box. There's a very, I'm in a country that was once Portuguese, and there's a very nice saying in Portuguese which says, many well-intentioned people go to hell. That's a bit harsh, but I'm just saying that, well, good intentions have their space, but they also have their shelf space. And it's true that as of today, corporations wield so much power that it's difficult to actually come up with a watchdog position on voluntary commitments. And we also know that political correctness, or they say wokeness, is very much a part of how we operate. But we also know from history, from different parts of the world, that voluntary guidelines are a good starting point. But how do we really make that journey from intention, like I said, from intention to intentionality? Probably that's just wordplay, but intent. But being really intentional about the change that we make, really the harm that we do. And I think many times for corporations, we've set very, very low bars, which is do no harm. And it doesn't work anymore because sometimes we don't know that we're doing harm. And AI falls into one of those areas where you're not sitting and coding a harm. You're just coding probably what you know. And what you know falls into the category that puts away millions and billions of women from the change from the lives that they want to have, particularly in terms of race and discrimination. So we must commit to principles that are beyond do no harm. But how do we create, like I said, a global AI observatory space that is not just by organizations like us, but larger corporations that do want to be on the front line of change? And we know that there are many. And we know that starting point is to demystify for organizations that have played in that space for a very, very long time. I wouldn't say very effective, but we've tried. Actually will only will be able to play that role when AI is demystified to us. Right now, it's a very black box for those who are on the side of social change. But like I said, it's time to upgrade our do no harm principles. And we have all three worlds that represent the lobby that it needs and the work that needs to be done.
I know we're reaching the end, so I'd like to ask just one more question to both of our panelists here. What are your key takeaways to us as audience listening to you in terms of how we should be looking at the future of adopting artificial intelligence, both in terms of creating efficiency and value to our organizations, and also how we look at challenges in the process of going through this? I would like 2 key takeaways from both of you.
Nishtha, you want to go first?
Well, I'd be happy to go first. For us as human women, there's one key takeaway is to bring to the table the intelligence that we've had of working with women, the data that we have, the collective power of the UN in actually influencing governments to collect data in ways that are sex disaggregated, but also reflect, like I said, the lived realities. So for me, the key takeaway is the urgency of the moment of all of us coming together and working together, like I said, the collective just wisdom in this room, and for organizations like us to come together to invest in research, particularly of what we know, what we don't know, but how also we can make it better. And a key takeaway for me on AI has always been not the typical UN stand, is to not, like I said, demonize AI, because it presents opportunity for change. And so for me, those would be the 2 things: believing in it and investing in it.
Great. I just want to say that, and it's not an original thought, I read it somewhere, it really resonated with me, which is that I think when the internet really democratized access to information, and that obviously has had a transformative impact across the world, I think AI has the ability to democratize intelligence, access to intelligence. I think intelligence can be infused into every nook and cranny of the world. and I think it's going to have, it's going to essentially, in my opinion, I think it's going to make what the internet did sort of trivial by comparison. I think it's going to be profound and transformative. But with any powerful dual-use technology, there are risks, of course, that come alongside. It's a package deal. So it really behooves us as a society to really understand what it is and make sure that we mitigate the risks while propagating the benefits as fast and as big as possible, because I think it has the potential to completely transform life on the planet in a good way. And then, unlike a lot of technologies like nuclear fusion or quantum mechanics or something, this actually is available to every one of us. We can literally go to chat.openai.com or whatever URL you care about, and you can actually access this technology, which is unprecedented. That has not happened before, which means that we actually have, we should play with it, experiment with it, really figure out what it's about, because without that knowledge, we can't collectively steer it towards sort of the best reward while minimizing the risk. So I think it's very exciting and slightly scary, and that is sort of the net of it, in my opinion. So I personally, I'm just happy that I'm alive during a time like this, because I think it's an incredible, seminal piece of technology, which gives me a lot of hope for the betterment of society.
Well, thank you both so much for your takeaways. I have a lot of questions here, so I hope that we can forward them on to you, Dr. Ramakrishnan and Nishtha, Satyam. Like we hope to get them to you so that our audience can hear the answers back. I definitely like to thank you both for your time and for your valuable input. A lot of things that we didn't know, we've heard, very educational. I also would like to thank the W20 India team that has actually given PKF O'Connor Davies an opportunity to be a part of this task force and a part of this very important conversation, which got us all together today. I'd also like to thank PKF O'Connor Davies team for putting this all together. My partners here, Kelly and Rachel, they've been amazing. Thank you so much. And we look forward to continuing this conversation. And the audience will definitely get an email as a follow-up from us, and you'll definitely hear from us. And if there's any questions that you have for our wonderful speakers here, please send it to us, to our contact information that you will receive. And we will have another round of webinar very soon about more interesting topics for you. So thank you so much, and we will end here. Thank you.
Thank you.
Thank you to our speakers, and thank you everyone for attending. Please remember to complete the short survey prompted at the close of this webinar. Again, a recording of today's webinar will be made available to attendees via email within the next few hours. Thank you again, and have a great rest of your day.
Bye-bye.
Bye.
Topics for you. So thank you.
Thank you.
Thank you to our speakers, and thank you everyone for attending. Please remember to complete the short survey prompted at the close of this webinar. Again, a recording